And thanks today for joining us. And hopefully you'll get some value out of this training session. We're going to talk about building operational excellence. We're going to talk about heat exchanger design, talk a little bit about distillation design, talk a little bit about pumps today. So that's kind of what we're going to talk about. KLM Technology Group, based in the USA since 1995, is a technical consultancy group providing specialized services and equipment to improve process plant operational efficiency, profitability, and safety. Our core business is training. We have 75 plus training classes similar to what we're doing today. Engineering design guidelines. If you've searched anything on the web, you've found our guidelines. We do engineering studies. We do HAZOP facilitation, engineering support. We sell process equipment. We sell random packing, structured packing. We have a engineering practice magazine, which I'll talk a little bit about. And we do evaluation of process units. We have a great magazine. We've been publishing it for 7 years now. I'm very honored. We've some months we have 30,000 readers, which is kind of amazing to me. And so we're published online for 7 years. And thanks for your support in supporting the magazine. If you have an article, we're looking for good articles. If you have a good technical article, come write an article for us. And with 30,000 readers, if you're an advertiser, you probably want to advertise in our magazine. So what are we going to talk about today? There are at least 5 parts to operational excellence. A partial list might include health, safety, and the environment, reliability, continuity of operations, quality, cost, and people development. So that's kind of what we want to talk a little bit about today. And then we're going to talk about heat exchangers, pumps, and distillation equipment, how to do troubleshoot some of them. Health, safety, and the environment. Health, safety, and the environment is the #1 concern. No project or operation can be classified as sustainable, which is the new magic buzzword, optimized or excellent unless it's done safely, healthy, while minimize the environmental impact. We've made great improvements in HSE in the last 50 years because we started from very, very poor performances. In the 70s, we had multiple deaths, multiple incidents. We killed a whole village, okay? So our HSE, we've done good, but we started from such a poor place. We've gone from an F failing grade to maybe a C average grade. We've done well, but there's still great room for improvement. Let's continue to improve HSE. if my student went from an F to a C, well, I'm a proud parent, but is that really good enough? All right. KLM has senior engineers with 35 years of equipment design, operations, and HAZOP experience to review your operation to improve your health, safety, environmental performance. So one of my complaints about HAZOPs is I don't see enough senior people in them. And so, you need to, let's don't be happy with a C. Let's try to continue to improve the HSE performance. Reliability, continuity of operations. A stable, reliable plant is the largest source of revenue. A reliable plant would generate more revenue than a plant with multiple outages. You should develop a team to review equipment reliability, design, operation, and the team should look for low-hanging fruits first. Often a few bad actors reduce the reliability of the whole plant. You should calculate the cost of unreliability and unavailable equipment. It's much larger than you would expect. Okay, so all through this presentation, I'm going to tell you to go calculate the money piece, all right? You got to calculate the money for things. Once you calculate how much money you're losing, then you're going to be motivated to go fix it. The best performing plants have greater than 97% availability. Many plants have less than 90%. For a large processing plant, this can be as much as $1 million per year per point. Okay, for a small plant, it can be $500,000. This is real money. Go improve your reliability. Of course, KLM can review equipment design and improve your reliability. The first team should look for low-hanging fruits. All right, so go calculate what your current reliability is. What's your percentage uptime? And whatever you're doing, let's have a goal to improve it. Quality. A company's quality is reflective of internal and external and internal aspects. External aspects. By developing and maintaining the company's reputation of producing quality products, you will allow you to charge a premium during the economic upturns and maintain your key customers in a downturn. Internal aspects. There's an added cost of non-quality production. Sometimes the product can be repossessed with an energy debit. If the product cannot be repossessed, it'll need to be sold with a cost debit. Again, go calculate what these numbers are. All right. Go calculate. Most companies have quality audits for the sole purpose of receiving a quality certification. That's certainly a good reason. But a better reason would be to utilize the audit to improve the product quality. Most audit findings are above 90% compliance. Amazing and not true. They're going through the motions of an audit. Okay? If you found 90% compliance, you're not really auditing. A good audit team can walk into any processing facility and find 20 plus non-conformance quality issues. I was on a team for a PSM audit. Previous audit 3 years earlier found 4 non-conformances. Our team found 37. The problem is that upper management will not be happy with finding non-conformance issues because they must deal with them. I've never understood this because it makes the plant more money, and with PSM, it makes it safer. Okay, so don't just go do an audit to put a certificate on the wall. Go do a real audit, particularly for safety. Go do a real audit. You should review your current quality standards and upgrade them to have a path to improve long-term quality. Again, the cost of non-quality production should be calculated. And again, it's going to surprise you what that non-conformance is going to cost. You do not have to reprocess very much product or sell at a reduced quality rate to be several $1 million a year. Okay. Our senior staff can review your quality standards and come help you do an audit. Okay. You'll be surprised how much quality costs. Cost control is a particularly important aspect of operational excellence. The 2 largest costs are feedstock and energy. We're going to talk quite a bit about energy. Sustainability is the new large topic of conversation currently. So let's talk a little bit about sustainability. Sustainability is a societal goal that broadly aims for humans to safely coexist on planet Earth for a long time. The quality of causing little or no damage to the environment and therefore being able to continue for a long time. So what are some sustainability buzzwords? Well, we've got green energy. And green energy is wind, solar, and hydrogen. We've got electric cars. We got blue energy. Blue energy is energy that you can recover from the sea. We got renewable kerosene and diesel. We got biodiesel. We got recycling and conservation. So we got this whole big group of buzzwords here. How should they actually be ranked? Okay. Right now, we're ranking them. Green energy is number 1, electric cars is number 2. That's our current rankings. But how should they be ranked? Well, I think they should be ranked like this. Safety should be number 1, and we said that in the safety section. Conservation, which is use less energy, should be number 2. All right. Okay. Recycling should be number 3. Green energy, solar, wind, and hydrogen. Blue energy from the sea, renewable kerosene or diesel, biodiesel, and electric cars. I put electric cars first because every real engineering study said we don't know the effect of electric cars yet. And so I put it last with question marks because we don't really know. But safety is number 1, conservation, use less energy. In chemical plants, there's a whole big range of things to use less energy. We're going to talk about some of them today. Distillation, heat exchangers. Heat exchangers are notoriously designed poorly. I'm going to talk about that. And pumps, we're going to talk about that. Recycling, green energy. So let's try to work on the top 4. Blue energy, we're developing, and we'll go from there. Conservation is a particularly important aspect of operational optimization. The 2 largest drivers are feedstock and energy. If I can use less feedstock to make the same more product, I can use less energy to make more product. An exceedingly small feedstock to high value product ratio gain can lead to an exceptionally large profit improvement. In 2 different plants, we did a $10 million profit increase just by, if you go to my LinkedIn, and I listed it, the different places where we saved over $10 million on feedstock. We made more product with less feedstock, twice. It's doable. A feedstock reduction team should be developed to review feedstock utilization. Many times, again, there's only a few bad actors leading to the loss of feedstock. Energy should be tracked weekly and monthly. Total energy should be tracked in energy per ton of high-value products. The industry standard for the major companies is energy is reduced 1 to 3% per year. The major companies, the top quartile major companies, reduce energy 3% a year. Most plants have the same energy performance or they're declining, while the best performing plants see an energy increase of 3%. Now, how can you do that? Well, I'll talk to you a little bit about that today. Heat exchangers are notoriously bad. Pumps are notoriously bad, and distillation is notoriously bad. So I'm going to talk about them 3 things and how you can improve the energy on them 3 things. Energy is a function of several items, equipment design, okay? Unfortunately, a lot of equipment's designed poorly, and we're going to talk a little bit about that. I've been doing this 40 years, and so it's like when I look at stuff and I'm going, how did they sell that? You know, it's just poorly designed. Plant reliability. Again, if I'm tripping offline, if I'm shutting the plant down, my energy is going to be very high. Motor power factors. So I'm consulting for a company in Southeast Asia, and I have them go back and track their energy use for the last several years. Every year it's trended up. And it's a catalytic process, and they bought higher efficiency catalysts. So it should have seen a trend down. So I'm in a meeting with a group of Asians. Of course, Asians aren't going to answer anything in the meeting. So I asked them, hey guys, there's something going on here. Your energy has trended up every year. Nobody in the room says anything. So after the meeting's over, the electrical engineer comes up to me and he says, well, what we're doing is we're buying the cheapest motors we can buy. And so instead of getting an 80 or 85% efficiency motor, which is called a power factor, they were buying 70% power factor. So they were losing 15% energy every time they replaced a motor. So every time you replace a motor, insist on 85% power factor or maybe higher. Don't buy a cheap motor. Pump efficiencies. With the current CFD modeling, pump efficiencies can be greater than 90%. Most of your pumps in your plant today are probably 80%. All right, how do I get this 3% a year? Well, every time I replace a motor, I buy a better motor. Every time I replace a pump, I buy a better pump. Lighting. So every time I walk around the plant, I see them buy new LED. I see them buying new fluorescent light bulbs. Don't buy any more fluorescent light bulbs. When your fluorescent light bulbs run out, switch to LED. Okay? Don't upgrade your lighting. Equipment installation. You can take a Polaroid camera. You can buy some infrared film. You can walk around and take pictures of your plant. You can tell very quickly where you need to repair your insulation. Heat exchangers. Heat exchangers are notoriously designed. I'm going to talk about this in this presentation. Distillation are pretty notoriously designed. They're also installed really, really poorly. Heaters and boilers. Most every heater and boiler I walk up to, they have too much excess air and they're wasting energy every time. And they've got an analyzer on the O2 and it's showing very low. But the problem with analyzers, the cell only works for about 2 months. You got to replace them often. And sometimes they're never replaced for 2 or 3 years. So you might, instead of running 3% excess air, which we won't, you might be running 6 to 8 excess air. Again, that's a huge number. Okay. So look at these things, how they're designed. If your energy cost is increasing, you need to put together an energy reduction team. Just forming the team normally sees a reduction in energy. It's amazing what increased focus can accomplish. You need to review heat exchangers, heaters and boilers, distillation. And a lot of stuff you can do just by adjusting operating parameters. I'll talk about that in distillation. There's things you can do just to decrease the energy, just by adjusting operating procedures. Every time you replace a piece of equipment, you should improve the energy efficiency of that equipment. That's how the industry leaders gain 1 to 3% a year, just by upgrading the equipment. You should not replace in kind. You should replace with a higher efficiency piece of equipment. And with the cost of energy today, it's actually going to pay its way back fairly quickly. Your team should be taught to specify replacement equipment for increased energy efficiency. There's going to be a small increase, okay? But again, you need to go calculate that money. So you're going to pay a little more for the piece of equipment. But over the life of the piece of equipment, you're going to make a lot of money in energy savings. You need to calculate that energy savings. Boss, go tell your boss, I'm going to spend $5,000 more, but the next 3 years, we're going to make $20,000. He's going to approve it. Pumps, motors, we've already talked about. Heat exchangers, we're going to talk about. Distillation equipment are all items that can be replaced with higher efficiency equipment. KLM will help you purchase each one of these pieces of equipment, all right? We can assist in specifying replacement equipment for increasing energy, often with only a small increase in cost. In fact, we buy a lot of pumps, and we might could sell you a high efficiency pump cheaper than you can buy your low efficiency pump. People development. The success of every company depends on each employee's understanding of the key business components. Employee training and development will unlock the company's profitability and reliability. When people, process, and technology work together as a team, developing practical solutions, companies can maximize profitability and assets in a sustainable manner. Training and development are an investment in your future success. If I'm a plant manager, okay, I'm going to look at my 2 biggest failure modes, all right? My 2 biggest failure modes are operator error and instrumentation. That's my 2 biggest failure modes, all right? If I was a plant manager, I would have a large training budget and I would have a large instrumentation budget so I could get a bigger yearly bonus. Go after the low-hanging fruits first. So I'd train my people better, and I'd have instrumentation budgets, okay? And I'm gonna sleep better at night. I'm gonna have more increased reliability, and I'm gonna have less errors. So I would invest in training and instrumentation. But if I go look, the training budget's always low and instrumentation's budget's always low, okay? KLM has several areas to help you support your team. Safety, process studies. We can do safety studies. We can do reliability studies. We can do quality studies. We can do cost control. We can do training for your team on the website. There's 100+ training. And we can do specialized equipment replacements, which we're fixing to talk about heat exchangers, pumps, and compressors, and how to try to do them better, all right? So we've conducted a number of process studies over a wide variety of processing plants, refining, ethylene, specialty chemicals, natural gas plants. We can bring this large database of knowledge to assist your team. Safety, reliability, quality, and cost control. Training for your team. We taught over 1,500 students over a wide variety of studies. We can custom build a training program for your team. And we kind of specialize in these 3 areas of equipment replacement: distillation equipment, heat exchangers, and pumps. So let's talk about some troubleshooting of these 3 areas. So we're recognized as a leader in distillation equipment, and we can do distillation studies, we can do simulations, we can do distillation engineer operation training, we can do tire inspections, okay? And we can replace equipment. So what are some major troubleshooting issues with distillation equipment? Number one is incorrect installation. Most places I go, they're not installed properly. And I'm fixing to show you some pictures. And even following the major companies that have passed it, I've gone behind them and found major errors. I'm fixing to show you some of these. Operation, if I go most places, operators are over refluxing the column. If I put too much reflux in, I'm having to run the reboiler too hard. I'm using too much energy. High pressures. Most columns I walk up to, I can lower the pressure. All right. Lower the pressure. I get better alpha Ks. And so I get a little better distillation efficiency. All right. So incorrect installation, over refluxing, and low efficiency equipment. Again, your purchasing guys do a great job of trying to get the best value they can. But by doing that, sometimes they get low efficiency equipment. So sometimes you have to specify a certain level of efficiency. I want this efficiency or better. And then there'll be a small cost debit, but you'll get it back a huge amount of money in energy savings. All right, so let's talk about installation. Most places I go, they're not really experts in how to install the distillation trays, packing, and different things. So a large problem in many towering is the incorrect installation, leading to a loss of quality product, lower tower efficiency. If I don't install them correctly, I'm going to have to run more reflux. I run more reflux. I'm going to have to run more reboiler. And run length, plant reliability. Many companies do not have the expertise to review tower internals. KLM can provide a senior inspector for your turnaround to assist in optimized tower performance. Typically, I'll bring a younger guy with me, and I ain't happy about climbing in towers, but I can climb in towers, okay? And so I'll bring a young guy. We'll go through. He'll take pictures. Anything I don't like in the picture, I'm going to go look at. And I'm telling you, all right, so what are things we want to look at? Downcomer clearance. We want to look at weir heights. We want to measure each one of these, make sure they're okay, all right? So here's a picture of a reflux piping that comes in. Now, it's supposed to come into this tray, come across to the back of this false downcomer, come across this tray evenly. That's what it's supposed to look like. All right, so it's just dumping on the top of this tray. Okay, just by dumping on the top of this tray, it disrupts this tray efficiency. All right, and it also disrupts the tray efficiency below this. All right, so by disrupting these two tray efficiencies, if I got a 30 tray column, I've knocked out 2 of the trays. All right, that's 6%. All right, I got to run 6% more reflux, and I got to run 6% more reboiler duty just by installing this incorrectly. This is my hand. I'm climbing in a column, and I'm measuring the downcomer clearance. So I'm climbing through a column. This is actually in India, and one of the majors companies had installed it, and they had already passed it. And I'm climbing through this column, and I don't like this right here. So these valves are sticking up right here. That don't look good to me. So a lot of times I'll kind of jump on a tray, or I'll move on the tray to see how tight the tray is. Well, I jumped on this tray, and it wasn't very tight. And I said, well, let me see how tight these bolts are right there. And I began to check the tightness on this bolt, and it just came out. And I said, wow, let me check the tightness on these 2 bolts. All 3 of them just came out. So I'm asking them, guys, what are you doing? Well, it was difficult we needed longer bolts. It was difficult. It was just, what's going to happen the first time I put feed in this column? This tray is going to come upset. It's going to wipe out about 4 trays. All right. You're probably going to decrease your capacity 20%. I'm not even sure you'll make quality products. Okay. So this is why it's important to install these trays properly. And even they had their internal inspector, they had a third-party inspector, and they had the tray manufacturer inspector. 3 people passed this. Guys, how can you pass this? This is common. This is going to cost you energy if you don't fix it properly. Distillation tray replacements. So we do tower inspections. We do trays, random packing, structured packing. KLM can replace distillation equipment at significantly lower cost than the major distilling companies due to our lower overhead companies, lower head cost. Most major companies have thousands of employees and worldwide offices, leading to a fixed high overhead cost. KLM has limited overhead costs, and we pass that savings on to your team. So we can buy you very similar quality. In fact, sometimes I specify higher quality, and then you can buy it at a significant savings also. Distillation tray replacements. All right. So here's some crude tower pictures. All right. So they probably weren't designed strong enough. I really don't like the type of valves that's there. And so if you're having troubles, you probably need to have KLM come in and look at improving your distillation trays. If you don't want to buy the trays from me, I'm okay with that. At least have me look at the specifications. All right. Have me make sure the specifications. So random packing, structured packing, demister pads. Have us at least review the selection. Stronger and more fouling resistant designs are very important for random packing and demister pads that have higher fouling failure rates. All right. Ethylene plant in Malaysia opened up their quench oil tower and found the random packing had disintegrated, causing very high pressure drop and fouling. Why did this happen? They opened up their column. All their random packing was in small little pieces like this. And it was just packed full with coke fines and fouling and all of this. Why did this happen? One cause might be galvanic corrosion. The packing was stainless steel and the tower wall was carbon steel. Always consider galvanic corrosion when you're designing with multiple metallurgies. Now, the original licensor, they bought carbon steel packing in the carbon steel walls. When they replaced it, the tray vendor sold them stainless steel packing. All right. So they didn't understand. You got quench oil column, you got steam, you got acids, you got all kind of issues here. And the galvanic corrosion actually just wiped out the packing. If your vendor doesn't want to sell you carbon steel packing, come to KLM. We'll order you carbon steel packing. All right. But always consider galvanic corrosion when you're designing for multiple metallurgies. All right. Opportunity loss here was well over $1 million. Energy loss and short run lengths. Okay, so you want on a quench oil column, quench water column in an ethylene plant, you want to match metallurgies. In a lot of places, you want to match metallurgies. Okay, so you want to be careful about galvanic corrosion. Gas processing. This picture of fouling in an amine column. The tower was packed with Paul rings. Paul rings have low efficiency and are not fouling resistant. Now, they've probably been specifying these Paul rings since the 40s, which is good if you want to drive a 1940 truck, okay? But there's much more efficient rings today, all right? So don't necessarily specify what somebody did in the past, all right? Okay, so obviously a much more efficient ring is IMTP, and amine are just going to foul, but at least get a little higher efficiency ring installed in an amine unit. Refining case study. Refinery upgrades metallurgy in the crude tower top trays to prevent corrosion. Is this the best engineering solution? So I go to a lot of refineries, and they'll upgrade the top 5 or 6 trays in the column to very high metallurgy so they won't corrode. And they'll spend lots of money on these trays. Is this the best engineering solution? So when I go to a lot of crude units, they end up replacing the top half of that column. All right. So what they've done, instead of letting the chlorides attack the trays, the chlorides now attack the wall of the column. It would be a better idea to have the trays, which are cheap, to be the sacrificial anode, and let the wall of the column stay intact. But what we've done over the years, we've consistently upgraded the trays, let the chlorides attack the wall of the column, and then we have to replace the top of the tower. So trays are cheap. A 1 meter tray, a 3 feet tray, is about $1,500, which is relatively cheap. The top of this crude column is not relatively cheap. Okay, so I'm not sure it's the best idea to upgrade the metallurgy. I would use the trays as a sacrificial anode and keep my tower shell intact. Operational excellence. It's important to understand the failure cases. All right. And here's another question. All right. Should a caustic tower have a stainless steel demister pad? We know caustic and stainless steel are not very compatible, but most caustic towers that I go to have a stainless steel demister pad. It would be a better plan to have a composite polymer type demister pad instead of a stainless steel demister pad. All right. And we know they're not going to last very long. The other thing I like to do is the bottom, I don't know, 3 inches, or the bottom, I don't know, what would that be, 75 millimeters, is to put a thicker mesh. And then the top part of it to put the thinner mesh, because the bottom is what always plugs. So don't put carbon steel or maybe stainless steel in caustic service. Go ahead and put a composite plastic. KLM, very, very competitive on demister pads, and we also design them better. So don't use stainless steel in caustic service, and have a little better design on your demister pads. Replacement equipment. If your current system has good acceptable run lengths, lower fouling potentials, consider high efficiency. You should not replace in kind without a view of the best replacement, or you'll not be gaining the 1 to 3% energy reductions. Compared to a conventional sieve deck tray, which is the industry standard because it's low cost and your purchasing guy is going to buy it, a high efficiency tray can see 5 to 10% efficiency gains, as well as 20% plus capacity gains. Distillation can be much as 50% of a plant's use. Okay? This can be 3 to 5% right here. Okay? A 1 meter tray costs $1,500. What costs a lot of money is the tower shell, the piping, the DCS, the electrical. All of this costs money. Trays are relatively cheap. Every turnaround, you should be replacing some trays with higher efficiency trays. Every time you replace a motor, buy a high efficiency motor. Every time you replace a pump, buy a high efficiency pump. Every turnaround, you should be replacing trays. You don't have to replace them all. Replace a tower this turnaround. Replace another tower the next turnaround. Replace another tower. And so if you replace in kind, or if you don't replace, your competitors are replacing and they're gaining this 1 to 3% a year. You have to replace your columns. Heat exchangers. Heat exchangers are designed poorly. They just are. Typically, and I'm fixing to show you, heat exchangers are designed very basic with limited optimization. If you're going to replace a heat exchanger in kind, you should not replace in kind. What you have is poor, and I'm fixing to show you. So you should not replace that heat exchanger in kind. If you have a fouling service, your heat exchanger should be designed to be more fouling resistant, improve heat exchanger, as well as reliability. Here's typical heat exchanger pictures. Everywhere I go, they look like this. Here's what they look like. And I'm fixing to tell you why. Okay. So what you have is I have a baffle right here, which goes all the way to the bottom. and the flow goes across the top and underneath and across the top. And I've got these baffles up here, which direct the flow different ways. All right. And if you're in fouling service, these baffles going all the way to the top are particularly poorly designed. Your heat exchanger should be designed to improve heat exchange as well as reliability. An improved design can increase heat exchange 10% or more. All right, so let's look at these baffles, bundles of tubes. So what I have this baffle right here, which kind of supports the tubes, okay? And it also redefects the flow, all right? If I have a fouling service, I've got a dead zone right here that's going to fill up with coke. It's going to fill up with polymers. It's going to fill up with all kinds of stuff, okay? It's just a poorly designed. I should have some kind of notches, either V notches or something underneath this baffle against the shell to where a small amount of flow will go this way, just to keep this area clear. Okay. So basically now it's going to have a little less efficiency. All right. But over the long run, it's going to have a whole lot more efficiency. Same way here. I don't want to be able to trap anything up here. All right. So what kind of baffles can I have? I can have all kinds of baffles. All right. So I can have this kind of baffle. Well, right here, I'm going to fill that up with trash. So I want to put some notches under here. Right here, I'm going to fill it up with trash. Right here, I'm going to fill it up with trash. And it's easy to put notches there. All right. And so right here, okay, I'm just going to fill up whatever trash I got. It's just going to fill up. I'll fill up that bottom section. I got 20% less efficiency in this heat exchanger. All right. So if you got a fouling service, you need to come to KLM. We will provide you, we'll bid on the heat exchanger. The minimum you should let us do is spec out the heat exchanger, because everyone you've got is poorly designed. Now, if it's clean kerosene service, I'm okay with this. If it's got any fouling potential at all, your heat exchanger should not look like this. Okay. And there's the pictures. Everywhere I go, they look like that. And it's like we'll design them, we'll fix them, we'll get you 10 to 15% higher energy. Okay. You don't need to look at that picture very much to know, well, if I had just some small notches underneath this baffle, I wouldn't have all this trash here. If I just had some small notches here, this stuff would move and not just be stacked up there. Well, I can guarantee you, I know what the heat transfer coefficient is right here. It's 0. The heat transfer coefficient from the bottom 20% of this heat exchanger is 0. Okay. So heat exchangers, if you're going to replace a heat exchanger, you need to come to KLM. What else about heat exchangers? Process design engineer designs for 120. Mechanical engineer will add 20% safety. So I have 140 to 144% of design. If I'm running at 80% of design, I may actually be running in laminar flow. All right. So what happens if I run into laminar flow? All right. So I have an extra layer of insulation right here, and I get very poor efficiency. If I have turbulent flow, that's what I want. All right. So as engineers, we tend to over-design things, which is great, except in heat exchangers where I can run into laminar flow. All right. There are several ways I can prove. I need to go run a study, determine if I'm in laminar flow or turbulent flow. All right. An easy way to do this, and I've done it several times, go plug some tubes. Plug 5% of your tubes. You might have to plug 10% of your tubes. You come up, your efficiency of that heat exchanger just goes up 30%. It goes up quickly. Add some inserts. I've got inserts I like and inserts I don't like. Okay. Some inserts fail pretty high. All right. You need to perform a study on your heat exchangers, determine the best fast forward to increase efficiency of the existing heat exchangers. Sometimes I can increase them. Sometimes you can actually pay to replace them. With these pictures, you could pay to replace some heat exchangers. Actually could. Okay. KLM has a senior team to specify and supply your heat exchangers. Our team's probably supplied 50 in the last 3 years. Because we supply many heat exchangers, we can provide you a higher efficiency, better design heat exchanger at the same cost you're probably buying. The minimum you should have us do is review your designs. Pumps, we've talked a little bit about this already. Current pump designs have higher efficiency due to safety modeling. If you're going to replace a pump, consider increasing the efficiency of the pump. KLM has a senior team to specify and supply your pumps. Again, we probably bought 25 pumps in the last 5 years. Because KLM buys many pumps, we can provide a higher efficiency pumps at the same cost you're currently purchasing. If you're only purchasing 1 or 2 pumps a year, the vendors are not going to give you a volume discount. Because we buy a lot, we get a volume discount. I probably can supply you a high efficiency pump at the same cost as you're currently buying. But there may be a small increase in cost, but it has a huge it has a huge return on investment. So here's a project that we put together on pumps. This is a 3D model, and here's the actual pump skid that we built. So there's pumps and there's motors, and here's some heat exchangers that we built. And so this is some of the actual projects that we've done. So we've talked about there are at least 5 parts to operational excellence. The partial list is health, safety, and environment, reliability, quality, cost, people development. We've talked a whole lot about heat exchangers. We've talked a lot about distillation. One of the big problems of distillation is installation. All right. Big problem with heat exchangers is not designed well. Big problem with pumps is I save money. Don't go save money. You're actually losing money in the long run. People development, go train your people. Okay. So that's kind of what's here's a project we did. We did a clay treater. Here's a CFD model of the clay treater. And there's the actual clay treater. You can see the pumps and the fin fans and the vessels. And here's the distillation system. And you saw these skids put together in the distillation system right there. All right. And there's the towers for the distillation system. So KLM, over 20 distillation products, 40 heat exchangers, 25 pumps, 20 pressure vessels. For a small project, you need to come to KLM. For large projects, we're not really big enough, but you do need to hire us to look at the specs of your equipment, because you can't buy the cheapest and expect to get good energy gains. Okay. Solid track record. Project since 1995, strength in process engineering, strong mechanical partners, wide range of industries, ready to assist for your next project. All right, let's see if there's any questions that's popped up here. No open questions. All right. So we want to thank you for your time today, and we've got this in the chat box. To get a certificate of attendance, you can send it to this link. And then, you can get a certificate of attendance. And we thank you for your time. And hopefully you've gained some value from the presentation today. And we've talked about health, safety, environment, reliability, continuity of operations, quality, cost, and people development. Also, I got some questions came up. All right. I can't see the link for the attendance. All right. So if you can't see the link for the attendance, send me an email. All right. Let's see if I can put it on this. And Don asked a question: when evaluating a distillation issue, do you ever use gamma scanning to check on the performance parameters and tray damage? Yes, I do. But I always do the simple checks first. Okay, so what I'm going to do, I'm going to run a pressure drop across the column. If the pressure drop is per design, okay, then the trays probably aren't the issue. All right. So I'm going to run a pressure drop across the column. If the pressure drops too high, I got a tray problem. If the pressure drops too low, I got a tray problem. So if I got a pressure drop issue, then I'm going to go scan the column. I think gamma scanning is good, but it's not necessarily the first thing I'm going to do. I'm going to go look at the levels. I'm going to go look at the temperatures, and I'm going to run a pressure drop across the column. Good question. That was a very good question. If you can't see the link for the attendance, send me an email, and we'll get you. In fact, at the last webinar, a guy sent me an email, and we sent him a link. It's in the chat box. If you can open up the chat box, you can see the. If you open up the chat box, you should be able to see the link to get to the form. Okay. So thanks for your time today. Here's another one. Does KLM deal with CO2 removable membranes? Okay. So can you supply membrane separations? Yes, we can. So membranes are typically a specialty, like a pump. You buy the membrane from a vendor, all right, and then you put it in a skid package, all right, and that's what we would do. We would buy a membrane from a reputable membrane producer. We'd put it together with the controls and build it in a skid package. Okay, so we could do. Send me an email. All right. There's not a link for the registration. Okay. All right. So it's in the chat box. If you open up the chat box, I hope you can see it. If not, send me an email. Membrane separations. Okay. So basically you buy a membrane from a reputable dealer, and KLM will put it together on a skid. You got to have some regeneration systems. You got to have some controls. Typically, you'll have a kind of a pump which picks up energy. All right, so you'll have kind of a turbo booster because you got to typically raise the pressure a lot. You don't want to just drop that pressure back down. So you'll typically have some pressure. You'll typically have a turbo booster to boost up the pressure so you don't lose it all. Okay, so there's several things that membranes are pretty well understood, and we have very good. I have very good partners to help build skids. You saw the pictures. We do very high quality work. Excellent questions. Okay. Thanks for your time today. And then if you have any questions, you can email me. If you can't see the link, just email me. I sent all of you got an email that attended today, so you can just answer that back. All right. And so thanks for your time.